Okay, this video is on what are called pitfalls. Pitfalls. Oop. Let's try that again. Pitfalls in statistics. Okay, so there's a number of places where you can make some pretty, bad mistakes because of just not being on top of things. So we're going to go through a list of 8 of these. So the first one is confusing two ideas. So it's confusing the idea of correlation and causation. Okay, so correlation versus causation. The example here could be that obesity and something like eating more and moving less. So someone who eats more and moves less and someone who's obese, these things tend to happen together. So we can say that they are correlated. But we don't necessarily know, or at least not without some additional investigation, whether or not one is causing the other. Is it that people who eat more and move less tend to be obese, or is it that people who are obese tend to eat more and move less? So here, to look at statistical information, we could get that these two things happen together. We don't necessarily know if the mechanization is there for being able to say that one causes the other. So this is the confusion of correlation and causation. Okay, so a second pitfall is working from reported results. Okay, so reported results can be problematic. So what I mean by a reported result is instead of actually measuring something, you ask someone what their measurement is. So like the classic example here is if you're asking someone to report their weight, it is likely that that weight is going to be radically different from what you would see if you actually put them on a scale. So here there's a chance for pretty significant error because someone is reporting their weight rather than you measuring it. Okay, so a third one here is something that's kind of difficult to pick up on sometimes, but it's when you're asking a loaded question. Okay, so in a loaded question, you are making a statement within a question. So like this is something like saying, should we deport Mexican immigrants in an effort to preserve American jobs? That's a loaded question. The question, should we deport Mexican immigrants, is in and of itself not loaded. That's asking an opinion. Whether you agree with it or not, it's asking an opinion. But adding that extra part on there of to preserve American jobs makes an implication. It makes an implication that deporting Mexican immigrants would actually create more jobs for non-Mexican immigrants in America. There's not necessarily a correlation there. So the question makes an implication that isn't necessarily true and leads you to answer one question when you're answering another. For example, if someone was asked, do you want to preserve American jobs? Sure. Then that's basically getting them to say, I want to deport Mexican Americans because I want to preserve American jobs, where there's not necessarily a connection between these two things. So we want to watch for loaded questions. Okay, so a fourth pitfall that we have is that you have to watch the order of questions. Okay, so if you ask questions in a particular order, you may bias your result. For example, you could ask the question, would you eat at a restaurant if you knew that their beef patties were grown in a lab? Okay, that question in and of itself is not problematic. If the next question is do you believe that you will be eating at Burger King this month, might skew the listener to think, oh, wow, the first question was about Burger King, and they grow their beef patties in a lab, so this is going to be, no, definitely I'm not eating at Burger King because I don't want lab-grown beef patties. So if I ask the questions in the other order, would you believe that you're going to eat at Burger King this month? Maybe. I don't know. Probably. Depends on where we go. And part B, would you eat at a restaurant if you knew that their beef patties were grown in a lab? No. So there, because of the order of questions, you are likely to get a very different results, and that's creating a bias in your results. Okay, so this brings us to number 5. Number 5 is going to be if I have a non-response to a particular question. Okay, so an example like this might be if you went out into the public and had a face-to-face interview, and one of the questions on your sheet was, do you regularly watch pornography? Okay, in that case, there may be plenty of people who are saying, I'm not answering that question, that's none of your business. Let's move on to the next question. If that happens frequently enough, then that reality is going to have an impact on your overall data. So if you have questions that are generating a non-response, you've got to look at why and make a decision as to whether or not that has caused a skew in your data. So that's something that could be problematic overall with your data. Let's look at number 6. 6 is missing data from a segment of the population. Okay, so in this case, you have a certain group within the population that is refusing to answer a question. Okay, so you may be asking something about like personally identifying information, and let's say it's a group of undocumented immigrants. They may, or within the population, the undocumented immigrants are reluctant to respond to that piece of data, saying like, where do you live, or how many people live in your home? These are questions that an undocumented immigrant might be reluctant to answer. If that segment of the population is not answering a particular question, then your sample is losing some of its randomness and its representation. It's no longer representative of the whole. So you have to be cautious about that, because now the responses are skewing away from that portion of the population. So if a group in your population is checked out from a particular question, you should be paying attention to who it is and why. Okay, so another thing that happens here is hyper-precision. Okay, sometimes people will put out their numbers that cannot possibly be known for certain. For example, you might say that, hey, the population of the world is 7,535,218,412 right now. And there's no way that that person could possibly know that number to that degree of precision. So when you see numbers that are hyperly precise and they are not possibly able to have that much precision, you should be leery of their accuracy. So that's a place where we can find error, is to say, look, I know this. Usually in cases like that, we might say it's between 7.5 and 8 billion people. That would be a much better way to describe the data than that hyper-precise way. Number 8 is people making percentage mistakes. When you do this, oftentimes it's confusing percentages with decimals. So these three numbers, 25%, 0.25, and 0.25%, are somewhat alike. These two are equal. They both mean 1 out of 4. This one is not equal. This one means 1 out of 400. So if you're looking at this number and you're thinking 1 out of 4, that is a percentage mistake. It's the confusion of how decimals and percentages interplay. This is 25 out of 100. This is 25 out of 100. Okay? This, if you think about this, is 0.0025. So this is 25 out of 10, 100, 1,000, 10,000. 25 out of 10,000 is different than 25 out of 100. This would lead to a percentage mistake and a misunderstanding of the data. Okay, so we've listed 8 possible pitfalls. There are more, but these are some of the common ones. Correlation versus causation, using reported results, using loaded questions, putting questions together in a bad order or a misleading order, having portion of the questions, or at least a question in your observation, be not responded to, having a group from your population not responding, being over-hyperly precise with your responses, and making mistakes using percentage signs and decimals.